Similar to the R commands for mean and median, finding the range is a simple matter of using the range command, which gives you the highest and lowest value. So let's use range for empty cars mile per gallon. All right, let's do it down here. So the range gives us the highest value. So the car with the worst gas mileage gets 10.4 miles to the gallon, and the one with the best gets 33.9 miles to the gallon. Now, as is probably not surprising to you at this point, the command to find the maximum car with the highest miles per gallon is simply max, and then you put in the variable. And conversely, the minimum one is min. R never is more complicated than it needs to be. Now, similarly, the interquartile range is found using the IQR command. Once again, you can easily do it by hand using R as a calculator. The quantile command gives us the different quartiles. So we go quantile, empty cars, mile per gallon. So it gives us the 25th percentile, 50th percentile, 75th percentile, 100th percentile. So if we subtract the 75th percentile from the 25th percentile, we get the, sorry, it was 22.8, not 22 minus 8. So 22.8 minus 15.425. Sorry, so that is the interquartile range. Or conversely, we can say, just type IQR, IQR capitalized, empty cars, mile per gallon, and that gives us the exact same number. Finally, to find the mean absolute deviation, one uses the MAD command, mean absolute deviation. The MAD command, however, requires that you specify that you want the mean absolute deviation and not the median absolute deviation by including a comma center equals mean, say x subcommand. If you do not include it, then the MAD command will automatically calculate the median absolute deviation. So let's do it here with the, again, empty cars, miles per gallon, and then we put in our subcommand, center equals the mean of empty cars, miles per gallon. And that gives us the mean absolute deviation. As noted in Khan Academy, another way to visualize these themes is through a box and whisker plot, or box plot. A basic box plot can be created using the box plot command, where the variable being measured is placed first in the command, followed by a tilde, that little symbol right there, then the variable by which the different plots are organized. Finally, the data set the variables are drawn from is referred to. So, in practice, this looks like this. We have our box plot command, miles per gallon, as our dependent variable, and then our tilde. Then let's look at cylinders, for example, the number of cylinders, comma, data equals empty cars. And that creates our box plot right there. Now, as with other graphs, with a little Googling, it's relatively easy to add y-axis labels, x-axis labels, overall titles, things like that. Finally, the standard deviation of a variable is easy to find with the SD command. So SD, miles per gallon, let's do miles per gallon, empty cars. It says it's not found. Oh, sorry. I reversed it. It's empty cars, miles per gallon. So that's our standard deviation for the miles per gallon of the cars in the empty cars data set. Because the variance is the standard deviation squared, we can find the variance by squaring the standard deviation. So we can just take this, variance equals standard deviation of empty cars, miles per gallon, squared. That creates our variance right here with this value. Or we can just use the var command, and this will give us the exact same results. 36.3241. So I hope you enjoyed this brief overview of range, interquartile range, and mean absolute deviation. This is our supplement for Khan Academy. Thanks for listening.